The first question that we've got here is about oil rigs. I'm talking about oil rigs drilling for crude oil. So we can understand that somewhere in this question later on, or maybe at the start, they'll ask for about some information that might relate to crude oil. So the question reads, drill heads are made from steel. Steel is an alloy. Alloy is a key word. We know that's probably going to crop up at some point in this question. Explain, so we're after reasons why. Explain why alloys are harder than pure metals. So we're trying to say why alloys are harder than pure metals. So we have to remember what an alloy is. So the first thing to remember is that alloys are a mixture of atoms, okay, of different sizes. Okay, so a mixture of elements, so therefore there's atoms of different sizes. So if I draw it out on the side over here, hopefully you remember, this would be like a pure element, okay, atoms of all the same sizes, so it's pure. An alloy would have atoms of different sizes in there, so it would have maybe some large ones like this, some smaller ones in there, okay, so you can see the smaller ones that I've drawn in as well. So what do we actually need to write to actually get the full marks on this question? First thing we need to write actually is what an alloy actually has within it. So you'd say alloys have atoms of different sizes, and what this actually does is it distorts the layers. So what I mean by that is that the layers aren't in regular patterns like they are for pure metal, so distorting the layers. So what this means is that the layers can't slide over each other as easily. So in a pure metal, these layers can slide over each other really easily. But because all these little atoms are in the way, because all the atoms are of different sizes, they can't slide over each other so well. This means the layers cannot slide over each other easily. Right, let's have a look at the next question. Okay, still continuing the trend on drills. Okay, still talking about drill heads when it comes to drilling for crude oil. They also say that they contain diamond. Now we know something specific. We know specific things about the structure of diamond. So describe as fully as you can the structure of diamond and the bonding in diamond. Okay, so we're after structure and bonding. You need to talk about both to make sure you get all 4 marks. It's a big question. Structure and bonding comes up on many tests. So the first thing with that diamond, okay, is what we call a giant covalent structure, okay, or a giant structure, or a giant lattice structure, or a macromolecule. Okay, the easiest one to remember from that is a giant structure. So diamond is a giant covalent structure. So the key thing out of this is that you've said it's a giant structure, which gets you 1 mark, and also you mentioned it's covalent, so that gets you 2 marks just from saying that. Now you've got to talk about what the bonds are like. We've said what the structure is like. Brilliant. We've got 2 marks for saying what the structure is like. We've got a mark for saying what the structure is like, but we've got to talk about what the bonds are like. Well, we've mentioned a bit about the bonding because we said it's covalent bonding, so there's 1 mark there. But we've got to mention that these bonds are strong. Okay, there are strong covalent bonds in diamond. Okay, and remember diamond is made up of carbon. Okay, so each carbon atom forms 4 bonds. So each carbon atom within diamond makes 4 bonds. With each carbon atom making 4 bonds. So a mark for covalent, a mark for structure, a mark for saying the strong bonds, okay, and a mark for saying each carbon atom makes 4 bonds. 4 marks there. Polymers, well, polymers are made from crude oil. So we predicted at the start that something would come up about crude oil. So they're saying describe the structure. Okay, so describe the structure and bonding again. They're asking for structure and for bonding yet again. And thermo softening polymers. Okay, so thermo is to do with heat, softening due to heat. Okay, something around those lines is what we've got to talk about. We've got to explain why they melt when they're heated. So there we go. So they soften when they're heated, so they melt when they're heated. Okay, so a polymer. This is related to polymers. So I think what polymers are. So remember, polymers are chains of molecules. Many monomers attached together. So there's chains. So polymers contain chains of molecules bonded together. Now, this is a thermo-softening polymer. That means that it must be easy to overcome the some of the bonds within this. So there's intermolecular bonds, okay, or there's intermolecular forces, sorry, I should say, between these chains of polymers, and they're weak, so they're easily to overcome. So one mark for saying what I've said here, saying that there's large molecules contain chains of molecules. Saying chain will get you a mark. For saying that they're large molecules will also get you a mark. So there are weak intermolecular forces between the chains that are easy to overcome when heated. So you've picked up the other 3 marks for this question just from that sentence. So saying that there's weak forces is the first part of it, saying that they're intermolecular forces is the second part of it, and saying that they're easy to overcome is the third part of it.